Welcome back to part 3 and part 4. This section will require you a calculator all the way, okay? And make sure you know how to use the modes too, alright? So guys, also just a reminder, on Schoology.com, you're going to find a keynote for SOHCAHTOA just in case you need a reminder of sine, cosine, tangent. So guys, I'm going to just show you with some examples how to attack these inverse sine, cosine, tangent, and calculator stuff, right? It says here, use a calculator to evaluate the function, always round to the nearest thousandth. And here it says, secant of 8 degrees in 50 minutes and 25 seconds, right? And how do you find that? You can't, I guess in your fancy calculator, you can probably cancel it. You can probably enter it like this. But I guess the first step you should do is change it to a degree, DMS into decimals, all right? So you guys, here's what I did the first step. Your first step should have been 8 degrees plus 50 over 60 minutes and 25 over 3600 seconds. And you should have got 8.841 degrees. And once you do that, second step, ready? You literally, on your calculators, here's the key that you have to press. It's right here. Under the control button, there is a trig button. If you press that, all the magic comes alive. And you should put in exactly the way you see it here. Secant of 8.841 degrees, or you can put 1 over cosine 8.841 degrees. Both of them would work. And you should have got something like this, 1.012. Make sure you're in the right mode, degree mode, okay? Next problem says, find the value of theta in degrees, 0 to 90 degrees, and radians, 0 to pi over 2. That means it's in the first quadrant, huh? You guys, interpret these well, okay? That's in the first quadrant. And you guys, it says here, find the sine of theta, 0.8191, or in cosine of theta, 0.0175. Are you with me? Wake up! So you guys, now it says here, so this is kind of strange. Usually we've been looking for the ratio. Now they want us to find the actual angle. That's when you have to use the inverse sine, cosine, tangent. Okay, guys? So here's what you do. You said, I want to see this equation every time. You're looking for the theta. You're given this. That means you put it as input. You guys, this is also on the trig function on your calculator. Inverse sine of 0.8191. That means you're taking the inverse of the ratio and you get the angle. And here's what you should get. 54.995 degrees, and also in radian, 0.960 radians. Make sure these answers all make sense to you. Like 54.995 degrees, is it about 0.96 radians? I think that sounds really good. How about here? Cosine of inverse, 0.0175, and that's equals to theta. Set it up the same way, but now if you're looking for the angle, you always have to find the inverse of the ratio. So you should have got something like this. Check that? All right. Next question. Okay. It says given this diagram here, find sine theta and find theta. Find tangent phi, that's phi, and find phi. So you guys, you have a missing side here, and this is the right triangle, so couldn't we do Pythagorean theorem to actually find the other side? So you're right, this guy is root 11, and that should set you up to find the rest. Now let's find a sine of theta. So sine of theta is 5 over 6, right? That's opposite over hypotenuse, so, and you have to find the angle, so you do the inverse, and you get this degree here. Make sure you guys are just kind of doing it on your calculator and just making sure that you know how to do it, okay? Now, now this is the part that I want you guys to remember. On your calculators, you guys, always make sure that you keep the integrity of this value. This is an approximate value, right? But in your calculator, there's this long value that goes on forever. So what you're going to do is, to find phi, aren't phi and theta complementary? So you're going to put 90 degrees minus the whole value here. And you should have got something like this. So don't just write this. Instead, just scroll up to that actual answer and actually enter that. So you should have got something like this. And then after that, you got phi of, tangent of phi is 0.663. But you guys make sure that answer makes sense. Another way to check that is, well, if you do tangent of 0.66, if you do tangent of 33.557, do you actually get root 11 over 6? That value should be agreed. Those values should agree, right? All right. Let's go to part 4, last part. Applications. All right. So applications, don't be afraid of them. Always think to yourself, I'm going to put myself in this situation, okay? So here we go. The angle of elevation and angle of depression are defined as follows. Make sure you have your notes out, guys. Okay, are you following along? So you guys, we have this picture here. The biggest misconception is, I will point that out. Imagine yourself standing here. You're looking up at this airplane. That's angle of elevation. Because there's a sky here, you guys, it's always going to start from the sky, and it's going to go up to the plane. Angle of elevation. Angle of depression, what if you're looking down at a car? It also starts from the sky, and it goes down. See how angle of elevation, angle of depression, they both touch the actual, they start at the same horizontal line. Okay? And also, if you're looking at the car and you're taking out this guy on the building, then there's also an angle of elevation. What? Oh my God! Isn't the sky and the ground parallel? That means alternate interior angles are congruent, huh? That means angle of elevation, angle of depression, they're the same thing, okay? Keep that in mind. Let's move on to the next problem. So you guys, we have this beautiful view here. Imagine yourself standing here, okay? Now, they want us to find the angle of elevation to the top of this building here. There's someone else hot over here. There's a guy here, that's you, and that's me. And you're checking me out, okay? So you guys, you're looking up at me. They want to know this angle here. That's angle of elevation because it's from the ground and you're looking up. That's angle of elevation. It's called theta. And you guys, here you have to determine something. What are you given? You're given, you want this, you need this, you have opposite, you have adjacent. You have opposite, you have adjacent. Oh, that's tangent. So you do tangent of theta is equal to 56 over 113. And how do you do this? Simple, simple, simple. You do inverse, right? 56 over 113. And did you guys get something like 26.362 degrees? You should have. Okay? Let's do B. What is the angle of depression from the top of the building to A? So you guys, I'm also checking you out. That means we're looking for this, huh? We're looking for this angle here. And we know, we just agreed that these guys are congruent because they're parallel to the same things. Right? So that's also theta. It's going to be 26.362 degrees. It's the same thing, okay? Let's go to the next question. Angle of depression from top of a building, on top of a cliff. This one's a little bit of a more difficult one. You guys, you have a cliff. How tall is it? Always draw a picture, 150 meters long. And what do you see? You see a boat. A boat. Okay, you see a boat. And there's a sea right here. You see a boat. And you guys, what is the angle of depression? It says here, it's 5 degrees. So you're looking at me from this boat. And the angle of depression here is going to be 5 degrees. Okay? Well, if that's 5 degrees, you guys, what's this guy here? That's also 5 degrees, okay? Just keep that in mind. Now, how much closer to the cliff must the boat be? The boat's moving this way. How much closer does the boat have to move in order for the angle of depression to be 14? So you guys, isn't it essentially doing this? I know I need to move this much amount in order for us to increase the angle of depression, right? That's about 14 degrees they want, right? So think about how much I have to move here. And that's going to be, that means this is 14 degrees. Okay? All right. So now, okay, let's look at this. We want to know this, right? But we're given all this information. So look, focus one triangle at a time. Isn't that a right triangle? Because the sky and the ground is perpendicular, right? At 14, oh, so what can we do? There are many methods, but I'm going to do this method, okay? I'm going to do step by step, each triangle at a time, okay? I'm going to actually erase that. So you guys, let's actually focus on the smaller right triangle. Let's actually call this guy X, okay? So if I do tangent of 14 degrees, because I'm given opposite and I need adjacent, 150, because that's actually at least part of this space, right? It's X here, opposite over adjacent, and I go X tan 14 degrees is going to equal 150. That means X is going to equal 150 over tan 14. Just algebra. And you guys punch that into your calculator, okay? Then did you guys get 601.62 around meters? That means this guy from here to here, it's going to be 601.62. Okay, we're almost there, but we need this. So you guys, we focus on this right triangle. Let's focus on the whole right triangle now. Okay? So we do the same kind of method, huh? So we do now tangent of 5 degrees. It's going to equal opposite, again, 150, right? 150 all over what? The whole thing. Why don't we call this another variable? The whole thing, let's call it a y. Okay? Let's call it y. So over y. The whole base is y. So I do the same algebra and I get 150 over tan of 50 degrees. That's 150, okay? And did you guys get something like 1714.5 meters? Okay? Okay. Well, wait, you know the whole? You have this part? You need this? Well, that's just simple subtraction. 1714.5 meters minus 601.62 meters. It's going to give you about, let's call this guy what we want, z. So z is going to be about 1112.89 meters. Okay? But you guys, think about it also this way, okay? Oh, and also, on your calculators, you know how these are approximate values? Try to only round once in the last step. So try to keep the integrity of these values, because these are approximates, okay? All right, next question, you guys. I want you guys to read the next question. Stop the video and sketch. And your sketch should look something like this, everything labeled. And try to do this problem using your eco-geo instincts. Remember how we use mirrors? We also use like mirrors and shadows. Try to do that, okay? And we'll go over it together in class. Bye!